Newton's second law states that a heavier object will have to be pushed harder than a lighter one in order to accelerate. So this law definitely has more to do with free body diagrams that I talked about in the first law calculations part, but it makes it so that you don't have to draw these kind of complex pictures, or you won't always have or be able to draw them. A free body diagram makes it much more simple and able to figure out more complex situations. So the situation here is a 30 kilogram bag of bananas is pushed right by the minions with 15 newtons of force. Friction resists this motion with 10 newtons of force, while gravity pulls the bag with 345 newtons of force. So, using the free body diagram, we can figure out the total amount of force over the F net that I'll be using, and then accelerate the acceleration of which the bag of bananas is moving. So, here's the free body diagram. And so, as you see the difference with the other one, we're able to kind of calculate more complex things with the free body diagram. And it's kind of represented just by this box here, and instead of like a whole picture or anything. So the free body diagram here is set up so that you can see the gravity pulling on the object is on both the top and bottom, and it's going to be the same. So the reason that it's the same is because, for example, if this number was higher, then that would be saying that the bag of bananas would be floating, or if it was lower, the other one, it would be underground, and obviously in this situation that is not applicable, and so the bananas are grounded. That is why those two numbers are the exact same. So these two here is the 15 newtons is being pushed to the right, so the arrow here on the right side has 15 newtons on it, so that's the amount of force that is being accelerated. That is why it's FA, and then FF is the friction that's being applied, so the 10 newtons of friction is here, so that is why it is on there, because it's kind of causing it to have less motion than this side. It's kind of pulling on the bananas. So in order to find the F net, it's super simple. So because these two numbers are the same, you don't need to worry about them. They equal 0. You just need to focus on this number here and this number here, and you would just do 15 minus 10, which is 5, and so that would give you your F net, because that's the total amount of force being acted on it, and that's able to be found with the free body diagram and with the properties of Newton's second law. And then also using Newton's second law and the free body diagram, you're able to find acceleration. So acceleration can be found by using this known formula that F net equals m times a. This is the mass and the acceleration, which is what we're going to be looking for. And in this situation, the mass of the bag is 30 kilograms, and so you do the F net found at the top, which is 5, equals the mass, so 30, times a, which will be the acceleration. And then from here, you just break it down to solve for a, divide both of them by 30, and you'd get about 0.17 when rounded up.